Hello dear, today I am going to talk about how can we differentiate any function using the standard results. Here now these all are some standard results, differential coefficient of elementary functions. D by dx x raised to n is n x raised to n minus 1 by x raised to n is minus n by x raised to n plus 1. These are some standard result. And this is here sine hyperbolic x. This is hyperbolic function and it is defined as sine hyperbolic x is e raised to x minus e raised to minus x by 2. Cos hyperbolic x is e raised to x plus e raised to minus x by 2. And now we get the sine hyperbolic x is cos hyperbolic x, it's dc. Cos hyperbolic x, its dc is sine hyperbolic x. Now I am going to use, how can we use this results to differentiate function. Some questions: find the DC of the following. This function is given and how can we differentiate? Find the DC. Here there are more than two functions. We can use here this result d by dx f of x plus by gx, this equal to d by dx f of x. For plus we can write plus, for minus we can write minus. So differentiating with respect to x. Why we are differentiating with respect to x? Because y depends upon x. Here function depends upon x, so we can differentiate with respect to x. Then operator d by dx using both sides. And now we can separate using this result. Now d by dx of x square. Here x raised to n, so we can use this result d by dx of x to the power n. This equal to n x to the power n minus 1. Here n is 2, so we can write 2 x raised to 2 minus 1 plus next 1 by x raised to 3. This follows by 1 by x raised to n minus n divided by x raised to n plus 1. So here n is 3 minus 3 by x raised to 3 plus 1. Next 2 is constant, so we can follow this formula d by dx c f x. We can write c d by dx f of x. Here 2 is constant, so we can take common, and now this will be in the form of 1 by x raised to n. So here minus 7 by 2 x raised to 7 by 2 plus 1, and this is constant. For d by dx constant is 0, so its dc will be 0. 2x minus 3 x raised to 4, 2 cancel, minus 7 x raised to 9 by 2. Hence dy by dx equal to this. Next, if y is now differentiating both sides. using operator d by dx, both side d by dx of this whole function e raised to x now we can separate each term d by dx e raised to x d by dx log x base 2 d by dx 1 by x raised to 3 by 2. Here a is constant, so we can take common d by dx sin x e raised to x. According to this result, e raised to x is e raised to x. Now next term log x base 2. This is not in the direct standard result. Log x base is 1 by x, but here log x base 2. So at first we have to change the base. Log x base e into log e base 2. At first we have to change the base convert into e, and then we can differentiate, then we can use the result. Here this is 1 by x raised to n, so minus 3 by 2 x raised to 3 by 2 plus 1. A is constant, dc of sin x is cos x, so e raised to x. Now log e base 2, this term is constant, so we can take common log e base 2 be outside of dc, and log x, its dc is 1 by x minus 3 by 2 x raised to 5 by 2 plus a cos x. Hence dy by dx is e raised to x plus 1 by x log e base 2 minus 3 by 2 1 by x raised to 5 by 2 plus a cos x. Now y is given sin inverse x sec x plus tan hyperbolic x. Similarly, we can do differentiating with respect to x, dy by dx Now d by dx of sin inverse x. Sin inverse x we can get 1 by square root of 1 minus x squared sec x into tan x, tan hyperbolic x, that is sec hyperbolic square x. So dy by dx is 1 by square root of 1 minus x square. For sec x into tan x, tan hyperbolic x, sec hyperbolic square x. If y is two x squared plus 6 by x to the power 3 by 2. Now here at first we have to separate each term. 2x square x raised to 3 by 2 plus 6 by x raised to 3 by 2 we can solve x raised to 4 minus 3 1 by 2 plus 6 by x raised to 3 by 2. Now differentiating with respect to x, dy by dx, d by dx 2x raised to half plus 6 by x raised to 3 by 2. At first separate 2 d by dx root x d by dx 1 by x raised to 3 by 2. For root x 1 by 2 root x. Here x raised to half, so according to x raised to n, half x raised to half minus 1. So here it will be 2 by 2 root x 6 minus 3 by 2 divided by x raised to 3 by 2 plus 1. 5 by 2, 2 cancel, 1 by root x minus 2 3s are minus 9 by x raised to 5 by 2. Hence dy by dx 1 by square root x minus 9 by x raised to 5 by 2. Now I am going to discuss the another result u into v and u by v4. If y equal to x square cos x, find dy by dx. Here y is x squared cos x. So this is the product of two functions u into v. So we can use first function dc of second function plus second function dc of first function. We can choose any function, be first or second. Differentiating with respect to x, dy by dx, d by dx of x squared cos x. So according to this result, x squared d by dx cos x plus cos x d by dx of x squared. So x squared for cos x, its dc is minus sin x. Cos x for x squared, x raised to n, that is 2x minus x squared sin x plus 2x cos x. Now if we have given three functions, like that, here are three functions, then how can we differentiate? Differentiating with respect to x, at first using operator d by dx both sides. Here we can use this result u/v/w for three functions. I am going to start from last. Two function as a constant and dc of the last function. Again two function be constant, second we differentiate. Again two function be constant, first we differentiate. So here e raised to x sin x d by dx of log x plus e raised to x. Now differentiate second function, e raised to x log x be constant, d by dx sin x plus d by dx of e to the power x, and here sin x log x be constant. So here we are starting from last. First two function constant, third we differentiated. First and third constant, second we differentiated. Second and third constant, first we differentiated. E raised to x sin x, for dc of log x is 1 by x. E raised to x log x, for dc of sin x, that is cos x, plus sin x log x constant. dc of e raised to x is e raised to x, hence dy by dx is, we can take common e raised to x from each term, e raised to x be common, so sin x by x plus cos x log x plus sin x log x. Now next question, u by v form. If y equal to x squared cos x by e to the power x, find dy by dx. This is in the form of u by v. Here y is x squared cos x by e to the power x. Differentiating with respect to x, d by dx x squared cos x by e raised to x. This is in the form of u by v. For u by v we have to use v differentiating u minus u differentiating v divided by v square. Here u is x squared cos x and v is e raised to x. So we can use this result, e raised to x d by dx x squared cos x minus x squared cos x u dv by dx, d by dx of e to the power x divided by v square. Now here also two function, it is in the form of u into v, both are different. So here we can also use u into v form, x squared d by dx of cos x plus cos x d by dx of x squared. X squared cos x and dc of e to the power x is e to the power x divided by e to the power x का whole square. E raised to x x squared, dc of cos x minus sin x, dc of x squared 2x minus x squared cos x e to the power x divided by e to the power x whole square. Here is also e to the power x, here is also e to the power x. So we can take common e to the power x. Now take positive term at first, 2x cos x minus x squared sin x minus x squared cos x whole divided by e raised to x whole square. Now one term we cancel, therefore dy by dx equal to 2x cos x minus x squared sin x minus x squared cos x whole divided by e raised to x. Here we have to discuss some standard elementary function sin x, cos x, log x, e raised to x, x raised to n, 1 by x raised to n, sin inverse x, u into v, fx plus minus gx, like that, c f of x, u, vw, u by v, like that form. This is the method we can solve, we can find the differential coefficient using the some standard result. So this is the method for using how can we find any function, any elementary function we can differentiate by this result. Now next is function of function and parametric form. So that is the different type of differential coefficient. At first we have to adjust into the elementary function. Here we have using this result, y is f of t and t is f of x. This is the function of function form. At first we have to differentiate y, that is if we have find dy by dx, then at first we have to differentiate y with respect to t and t with respect to x. Then we get the final result dy by dx. So this is the form of function, or we can also say chain rule. Now next class we discuss about the function of function and parametric form. Okay, thank you.